Ejected by the sun is not constant reconnection events in the sun's magnetic field can release huge amounts of energy in the corona, ejecting millions of tons of charged particles into space in one big eruption. This is what is known as a coronal mass ejection, or CME. When these CMEs interact with the Earth's magnetosphere, it causes what's called a geomagnetic storm. And the biggest of these storms can be devastating. The largest geomagnetic storm ever to hit Earth was the Carrington event back in 1859. If such a CME was to hit Earth now, the resulting storm could affect satellites and our electric power supply in what could be described as a hemisphere-wide EMP bomb, as we depend on electricity and the internet so much, even a few hours of outage could cause serious problems. Some estimates show that if a Carrington-sized event happened today, it could cause a few $1 trillion in damages. And unfortunately, CME flares are fast. They've been shown to reach Earth in just 17 hours. This might not be enough time to alert the entire population. Turn off reactors and take necessary precautions. In reality, we have simply been lucky up until this point, as we missed a Carrington-sized event hitting us by a margin of 9 days. In July 2012, had it been 9 days later, Earth would have been a bit further in its orbit and in the CME's path. This is why it's so important for us as a delicate species to understand the sun's corona, so we can better predict solar storms, to give us better warning and hopefully avoid damages associated with a Carrington-sized event actually hitting us. It's just a matter of when, rather than if now. These two probes may seem similar. And while a lot of their goals do overlap, they both have some unique features. The Parker probe is going deep into the sun's corona, where no man-made object has gone before, because it has to withstand such high temperatures. The spacecraft is limited in some ways. For example, it cannot take pictures of the sun, as no current camera technology could look directly at the sun from that close and survive. But the Parker probe has instruments that can directly sample and collect data about the particles that exist in the sun's corona, and even closely study the regions where solar winds originate, something that can't be done at a distance. The Parker probe is lighter, smaller, and has less equipment compared to the solar orbiter. The solar orbiter, on the other hand, carries both particle detectors and telescopes. It can take close-up pictures of fascinating solar landscapes. And due to its orbit, it will be able to track a region of the solar atmosphere for much longer than is possible from Earth. This will enable it to observe storms building up in the atmosphere over several days, so as you can see, these probes are complementary. And both will help further our understanding of the sun's corona in their own way. So what have these missions achieved so far? Well, on the 27th of September 2020, the Parker probe passed within 13.5 million kilometers of our star, the closest any spacecraft has ever been. Also, it became the fastest traveling human-made object ever, traveling at 66,000 km/h. And this isn't even as close or as fast as it's going to get. Still, even at this distance, the data sent back from the Parker probe is already helping our understanding of how the sun's magnetic field and the corona inked to form solar winds. The probe also discovered that some magnetic fields from the sun sweep through the solar atmosphere, which can increase the solar wind speeds by as much as 500,000 km/h. In addition, it is discovered with evidence of a dust-free zone 5.6 million kilometers from the sun. It's believed this is due to the vaporization of cosmic dust particles by the sun's radiation. The solar orbiter has already sent back its first images of the sun, and scientists found something called campfires, which you can see here. These are explosions on the sun's surface that occur as a result of disturbances in small magnetic fields. The solar orbiter also took the closest images in existing distance of the sun's surface from 77 million kilometers away, and the examination of particles across its orbit will help us understand the different types of space. Music. Weather. The sun is a giant, bright celestial object of intense nuclear. Music energy. It unleashes billions of tons of electromagnetically charged plasma hurtling into space every day. These violent eruptions, called coronal mass ejections or CMEs, shoot off into the solar system, causing what we know as solar music storms. These highly charged plasma particles race towards Earth at over 1 million km/h, and one might think that with the speed and intensity of these particles, we should all head for the bunkers when they arrive. However, the Earth has natural protections in place to prevent most of these particles from hitting us. One such protection is the Earth's powerful magnetic field, which pushes the particles around the planet and to its poles. Music particles that do hit the atmosphere are absorbed and provide the energy to drive the climate on our planet. In fact, the sun is crucial to life on Earth. For example, it provides just the right amount of warmth and light so that plants can photosynthesize the sun's energy to usable carbohydrates. This energy makes its way down the food chain until it reaches us humans. We eat and convert food to give us energy that our bodies can use. Almost all food. Energy can be traced back to the sun, our life giver, and the very beginning of our food chain. But could the solar system's giant also create catastrophe? How big can these CMEs get? What if the largest solar storm of all time was to hit Earth tomorrow? Could the sun actually damage or destroy humanity? Music for a star are